In this video, we are going to talk about how to add vectors, right? See, you know how to add numbers, right? What happens? First, you study about numbers 1, 2, 3, 4, and so on, and then you study about how to add these numbers. 1 plus 2 is 3, 3 plus 10 is 13, and so on. So now we have studied about vectors, its notation. Now we will talk about how to add vectors. And what are the rules of addition of vectors? Suppose I have two vectors. I have this one vector a bar and another vector is b bar. Right? I want to add these two vectors. Suppose the magnitude of a bar is 5 and magnitude of b bar is 3. Now the thing is, vectors do not add just like numbers. You add numbers like 5 plus 3 is 8. Now a bar plus b bar will not have the magnitude of 5 plus 3 equal to 8. It is not like that, it is different. So I will show you how you will find out the magnitude of the resultant vector in upcoming videos. Now you see from here that a bar and b bar are two vectors, and somebody asks us what is the addition of these two vectors. So if you want to find a bar and b bar, right, then I will write this as my first vector. I will write this as my first vector. I will write this as my second vector. Why? Because I am writing it first, that's why it is first vector. I am writing it second, that's why it is second vector. Now according to this law of vector addition, actually there are two laws of vector addition. The another law we will study in the next class. This law of vector addition, according to this law of vector addition, triangle law of vector addition, if you want to add these two vectors, then take the second vector's tail and put it on the head of the first vector. So if I have a vector like this, a bar, then you take the tail of the second vector and put it on the head of the first vector like this. What I am doing here is I am translating this vector like this. Why I am doing that? Because see, if you translate this vector, it doesn't change the meaning of this vector. In our previous video we have talked about that. Translating the vector doesn't change the meaning of that vector unless you rotate it. So of course I can translate, I am free to do that. So here, now according to triangle law of vector addition, the resultant of the addition of these two vectors is the vector starting from the tail of the first vector and ending at the head of the second vector. So the resultant vector's tail lie on the tail of the first vector and head lies on the head of the second vector. So this is going to be your a bar plus b bar. This is your resultant vector. This is the vector addition that I am talking about. Now this looks like a triangle. That's why it is called triangle law of vector addition. Again, I will repeat triangle law of vector addition. What does it say? It says that take the tail of the second vector and put it on the head of the first vector like this, and your resultant vector, that is the addition vector, is in such a way that its tail lies on the tail of the first vector and head lies on the head of the second vector. So this is going to be your triangle. Now suppose I have now note that if this is from this triangle itself, you can see, right, this is 5, this is 3, that doesn't mean it is 8. The two triangles sides, if you add 5 plus 3, then you will not get this side to be 8. So it is not like that. So to find out the magnitude, we will see another law which is called parallelogram law of vector addition. So let's not talk about it now. Let's talk about this. So it is forming a triangle. Another example you take. If you have a vector p bar and another vector like this q bar, and I want to add these two vectors, then that means I want to write p bar plus q bar. Now what you have to do, you have to take the tail of this second vector and put it on the head of the first vector. So this is my first vector p bar. Take the tail of the second vector and put it on the head of the first vector, and then the resultant vector will be this. Tail will be on the tail of the first, head will be on the head of the second. So if you get confused in this, just imagine this is your first vector, this is second vector. See, you are walking from this to this, right? And after that you walk from here to here. So your net displacement is from here to here as only, right? So you displace yourself from here to here, then you go from here to here. That means eventually you have gone from here to here. That is all. That's how you can remember this triangle law of vector addition. Okay, yeah. So remember, the magnitude of this plus magnitude of this is not equal to magnitude of this always. In some cases, yes. In some cases, no. Many cases, no. Only few cases are there. I will show that. Okay. So this is what all about that. Let's talk about the case where addition of this is nothing but the addition of individual magnitudes. Let's talk about that. Okay. Suppose I have two vectors like this. This is a vector A bar. This is another vector B bar. And note that these both vectors are in same direction. These both vectors are in same direction. Okay, let's find out A bar plus B bar. Let's find out A bar plus B bar. Now your B bar is a second vector. Okay, so B bar is a second vector. I will put the second vector's tail on the head of the first vector. So that's what you say in a triangle law. You take the tail of the second vector and put it on the head of the first vector like this. Okay. Now what will be the resultant vector? Resultant vector will be the vector which starts from tail of the first vector and end at the head of the second vector. So if I draw the resultant, on top of it I will not draw because it will confuse you. Like this. This is your resultant vector, A bar plus B bar. What I have done here? I have added this and I have found out that the magnitude of A plus magnitude of B is nothing but the magnitude of A bar plus B bar. So in this case, there are two observations that you should make. First observation is there is no triangle formation. We call it triangle law of vector addition, but there is no triangle formation here. And another thing is, in this case, the magnitude of addition of two vectors is a summation of magnitude of these two vectors, right? So that is what is observed here. So imagine, right, a real life example you can take. Suppose there is a block and I am pulling it in this direction with a 2 Newton force. You come up with me and you start pulling it with 3 Newton force. Now both the forces are in same direction, they will end up adding. So it is same as pulling it by 5 Newton force. So here it is addition just like a magnitude, right? Okay. But now don't get fooled by this positive sign. It does not mean that always the magnitude of resultant will be greater than both of these magnitudes, right? It is not necessary that it is always greater than both of this magnitude. I will tell you one scenario in that it will not occur. Suppose I will have this vector A bar and another vector is B bar, right? Okay. Now I want to add these two vectors, A bar and B bar. I want to add these two vectors. Now A bar magnitude is 5, let's say, and B bar magnitude is 3, right? B bar magnitude is 3. Now I want to add these two vectors. What I will do, I will take this second vector's tail and put it on the head of the first vector. So if I do that, see, this is your A bar vector. B bar vector's tail on the head will be here and B bar vector will be somewhat like this. Correct? A bar is like this, B bar is in opposite direction. Now according to triangle law of vector addition, your resultant tail lie on the tail of the first vector and head lies on the head of the second vector. So this is going to be the addition of this. Now here actually what is taking place? Subtraction is taking place. So here no, don't get fooled by this positive sign. It doesn't mean that always the magnitudes will add. It can be lesser than either of these magnitude. So here if A is 5 and B is 3, from here you can see this length is A minus this. A is 5 and B is 3, so this will become 2. If it is in 4 system also, so let's call it as 2. So the result here is 2. So it is not greater than 5 or not greater than 3, right? It is lesser, right? It is lesser than 5 and 3 both. So don't say always it will be adding, it is always greater. No, than either of these, not like that. Okay. So here these are called anti-parallel vectors. Anti-parallel means, see, they are parallel lines but the directions are opposite. That's why they are called anti-parallel. Okay. So in this case you subtract the magnitudes, right? So we saw the case where the triangle is not formed and where the numbers add up or directly subtract. Example of this is again the same. If I pull this by 5 Newton and if you are pulling with 3 Newton force, then eventually you will end up with a net force of 2 Newton towards right direction. So this is an example of that. Okay. Right? Okay, so let's end our video over here. Thank you.